Hello everyone, welcome to Can.Do.So. This is Ready. What the last two episodes we covered the normal distribution. What is normal distribution and how to use normal distribution. And today I'm going to show you the central limit theorem, because with the central limit theorem, the normal distribution will be much more useful. First, we know the package we use. It's Tidyverse. Okay, what is central limit theorem? The central limit theorem is says that the distribution of the average of a large number of the independent identical distribution, which could be short as IID, variables will be approximately normal regardless of the underlying distribution. Okay, what does that mean? It means no matter the distribution is, for example, it could be normal distribution. Excuse my, okay, excuse my bad drawing. For example, it's a normal distribution or a uniform distribution or chi-square distribution or any other distribution. If we take a, for example, if we have a lot of samples, this is one sample, its distribution is like this, and there's another sample of the normal distribution or another normal distribution or another distribution of uniform distribution or another form of distribution. For each sample, we can take a average. We can find out their average values. For example, it's here, it's here. For example, if, for instance, we have 100 samples, then we will have 100 means. We take every sample and to get the means, and then if there's 100 samples, we got 100 means, 100 means, 100 means. Then the 100 means will, no matter this 100 means, this 100 means, or this 100 means, or this 100 means, they will be normally distributed. Normally distributed. If the number is much bigger, 1000, it will be more normally distributed. And so let's use an example of chi-square distribution to show the central limit distribution, central limit theorem. Chi-square distribution is a right-scale distribution. It used to test the goodness of fit of a model, or it also used to test the independence of two variables. We will learn more about it in the future lesson, but here we just use it as an example to show central limit theorem. For example, this one, we create a chi-square. This one means sample size is 100, so we create a $100 100 data, which distributed as chi-square, and the degree is 5. You don't worry about the degree of freedom is 5. What it does mean, we will cover it when we will learn the chi-square itself. And we use a ggplot to make a histogram and density. and it will be like this. Yeah, it's a right skilled, right? You can see that right skilled, which means there is a long right tail. And what does this distribution ring a bell for you? Yes, I think if we take a example of rush hour from 7 to 12 in the morning, how many people are in the queue of the, for example, a bus stop. So in the very early, there were few people there, but as about maybe 8 to 9, there will be much more people are waiting in the queue in the bus stop. And after 9, it will extremely reduce to very few people, because most of them has got into their office or position to start work. So we're much fewer people. And we can try a different size of the sample and the degree of freedom. We can see what's the distribution will change. So let's go to the R. So we change first we change the degree of freedom. So as the degree of freedom increase, the peak will smoothly move towards to the right side, which means the long right tail will become much shorter. And we change to 20. You see, it's in this case, it's almost not right skilled. You can do it again. Still a little skilled. So about 30. Yeah. But again. Yeah. If it's a 30, it's almost it's a little like a normal distribution. So we change back to the 5 degree of freedom, and we change the sample size to 1000. Yeah, this is more typical a chi-square with a peak in the beginning side and a non-right tail. Change it to even bigger. Yeah, it's great. So if you want to practice this, you can use this code. Here is a bend and show. Click this button to copy and go to the R, insert a chunk, copy it, and yeah, that's simple. So we got a basic idea of the chi-square. So now we go. I'm going to show you the central limit distribution. So in this case, we have 100 sample with degree of freedom as 3. Okay, we got this size, this distribution. We can repeat it again with the same sample size and the same degree of freedom. It's almost the same. And again, yeah, we can see that it's not the distribution of the three samples are chi-square distributions, which are right skewed, but they are absolutely not normal distribution. So how about we change the sample size? Sample size, okay. Yeah, just as we showed. If the degrees freedom is not as big as 30, so it will be typically chi-squared with non-right tail and the peak at the left side. Okay. Here we got three experiments. So now let's take 10,000 experiments with a sample size of 10. Okay, sample size of 10. Degree of freedom is still 3. Okay. You can see in this case, which means in each case, in each experiment, we got 10 data, and the 10 data is roughly chi-squared distribution. And with each, we take a mean, we take a average value, and we repeat 10,000 times, so we got 10,000 mean. And the 10,000 mean will roughly follow the normal distribution. But here, because the sample size is just 10, so it's not a good normal distribution with little, you can see that the right tail is still longer than the left tail. Okay, how about we reduce the sample size to 5? Okay, that's even longer right tail than the sample size of 10. Okay, here we have tried the 10. And how about we change it to 30, sample size change to 30 here. And also we make a 10,000 times of experiment. Okay, you can see that the right tail is almost near, close to the right side, left tail. And we changed to 100 sample size. Okay, you can see that it's almost a perfect normal distribution. So we get the idea that we can see that the distribution of the average of each sample is more like normal distribution as the sample size increases. So we tried from sample size with 5 and 10 is this one, and 30. So 30 is very close to normal distribution, and 100, sample size with 100, it's almost a perfect normal distribution. So you get the idea that as the sample size goes up, we get a very good sample size of normal distribution. Yeah, this is a experiment of sample of chi-square, but if it's not chi-square, if it's this one is This one is a uniform distribution. And this one is a two-peak distribution. And this is a chi-square distribution we have just covered. And this one is a normal distribution. So if the sample size is 2, this one is not close to, not a very perfect normal distribution, but close to. And if it's two peak with sample size with sample size is 2, it's not. Chi-square sample size is 2, it's not. But if it's a normal distribution, then sample size with 2 is, of course, it will be a normal distribution. And if we go to the sample size with 5, then the uniform will be much more like that, and the two peak is much more like. And chi-square still a little right-tailed, but better than this sample size with 2. And the normal distribution will become narrower and narrower because the standard deviation of the sample mean of the sampling distribution will become much more closer to the mean, to the real mean. And if we continue to increase to 30, and almost everyone becomes a normal distribution. So that's why we say that we say that the sample size is large enough when it is greater than 30, then it will be the sampling distribution will be a normal distribution. Okay, I think that it gets the idea. Thank you for watching. Please like and share and subscribe my channel, and so I can offer you more and much better tutorials of the data analysis with R. Okay, see you next time.